Okay. Multiplying matrices right here, right now. So multiply two matrices together. There's a rule for this. Let's figure out the rule. Dimensions. Your first matrix is a 2 by 3. The second one's a 3 by 5. You want to know, can I even multiply them together? Like, what's the rule? So here's the rule for multiplying matrices. Here it is. A 2 by 3 and a 3 by 5, you can multiply together if, and only if, this and that, this number and that number are exactly the same. If they're the same, then you can proceed. Yes, you can multiply them. If they're not the same, no, you can't. It's like 3 and 3, they're the same. Like, yeah, I can multiply these together. I could do this. Let's look at the second one. This is a 1 by 4, and this is a 4 by 3. So the question is can I multiply them together? Like, can I proceed? Can I attempt this? Let's check. Here's a 4, here's a 4. They're the same number. Yes, you can. So yes, you can multiply those together also. So here's the deal. This is a 2 by 5, and that's also a 2 by 5. Like, they're the same dimensions, a 2 by 5 and another 2 by 5. Now, you could add those together, but the question of today is, can you multiply them? Like, well, let's check. This number, that number, no. They are not the same number. That's a negative. Not going to happen. Oh, I'm going to give you guys a little bonus feature today. Just take a guess. Dimensions of this is 2 by 3. Dimension of that is 3 by 5. If I were to multiply this together, the 2 by 3 and the 3 by 5, what size would it be when I'm done? Like, what's the dimensions of my final answer? A 2 by 3 and a 3 by 5. All right, I'll just tell you, it's kind of a slick move. See the first number and the last number? That tells you what your final answer will look like. It'll be 2 rows by 5 columns. Let's say you got a 1 by 4 times a 4 by 3. Final answer will be, oh, that's a 1 by 3 is what that'll look like with its dimensions. Okay, we've been talking about multiplying matrices. Let's actually multiply the matrices. Let's do one. All right, here we go. Okay, I've got a couple of 2 by 2s right here. How about 5, 3, negative 1, 1, 0, 4, 2, negative 6. All right, so I've got this matrix, that matrix. The question is, what's the dimensions? Can I proceed? This is a 2 by 2. That is also a 2 by 2. So the question is, like, can I multiply these? Like, oh, yep, same. So yes, I can proceed from here. Now here's how you start these. This is what you do. It's always the rows of the first one. So you always want the rows of the first matrix, and you're connecting with the columns on the second one. That's how you split these up. Rows of the first one connect with columns of the second one. I don't have a big enough camera for the whole board and stuff. All right, keep this on your paper. I got to erase it off my board, and then I'm going to do the rest of the problem. So I'm going to fit the rest of the problem on here. All right, let's run the connectors. I got 5, 3 that's going to hit both of those. All right, so my 5 and my 3 was my first row. So there's my first row, 5 and 3. Now he has to hit both columns, so you got to run the 5 and the 3 over there also. So 5, 3 on this side for the first row, 5, 3 hits the second one too. And then your bottom row was negative 1, 1. Leave you some room to work. So the negative 1, 1 from the bottom row, it hits both columns. Okay. So the 5, 3 and the 5, 3 connected from row to columns. So now you fill in your first column, which was 0, 4. So here's 0, here's 4. And then your second column was 2, negative 6. So there's 2, negative 6. And then your bottom row hits first column, and your bottom row hits second column. So the 0, 4s, they drop down. the 2, -6 also fill in. So now you've got your setup, connected, linked up, ready to go. You've got tiny little math problems. Let's see here, 5 times 0, that's 0, plus 12. So your first answer is going to be a 12. Negative, that's 0, plus 4 is 4. 10 plus -18, that's -8. -2 plus -6, that's also -8. So what you're looking at then is you got this 12, you got this 4, you got this -8, and that -8. So when you try to run your final answer matrix, see if I can just slide it in right here, 12, 4, -8, -8. So this bad boy right there, final answer, 2 by 2. Okay, not bad. A little smaller one, a little 2 by 2. 2 rows, 2 columns. Everything's nice and neat. Let's try where things get a little bigger, a little larger scale. Oh boy. Yeah, I'm going to need a giant board for this. I don't know if I can make it all fit. We're going to try. Okay, let's make it happen. Here we go. So I've got this, 4, 0, 1. I've got a 2, 2, -1. Got this matrix, -1, 3, 5. 0, what do I have right there? 2, 4. Okay, so now we're going to attempt to multiply a matrix times another matrix. We need to check to see if we can actually proceed with the problem. Is it allowed? So we need dimensions of this. Rows by columns. So this one is a 2 by 3. 2 rows, 3 columns. This one is the other way. You have 1, 2, 3 rows by just 2 columns. All right, here you go. This one 2 by 3, that one 3 by 2. Question is, can I multiply these? Can I proceed? We check it. Boom, boom. Yes, you can proceed. Ooh, bonus question. When I'm all said and done, what's the size of my final matrix going to be? Like 2, 2. So my final answer is going to be a 2 by 2 somehow. Oh, you can't quite see that. I'll write it right there. 2 by 2. Wonder how that happens. How does a 2 by 3 and a 3 by 2 end up to look like a 2 by 2? We're about to find out. Okay, guys, here we go. Remember, it's the rows of your first matrix, rows, connect with the columns of the second matrix. Now I've got to erase this off the board because I need this whole space to dry up this giant grid of numbers we're getting ready to put up there. Rows connect with columns. Rows, columns. That's the way we run it. All right, let's get the problem out of the way and start the process. Now, you're going to need a lot of space because that first row has to connect twice. So 4, 0, 1 has to connect 2 times. So we got 4 plus 0 plus 1. 4 plus 0 plus 1. Hopefully that's on the camera. I think it is. So 4, 0, 1 has to hit the first row. The first row has to hit the first column, and the first row has to hit the second column. There's 4, 0, 1. Let's get our second row. That was the 2, 2, -1. 2, 2, -1. 2, 2, -1. Okay. Rows have to connect with columns. I've got all my rows all ready to rock and roll. Now I just got to fill in the columns they connect with. -1, 3, 5 was my first column. So the -1, 3, 5 all hook up. The second column was a 0, 2, 4. So this will be 0, 2, 4, 0, 2, 4. So you've got every math problem set up, ready to go. You just got to go in and do a whole bunch of tiny little math problems to get your answers. All right, let's roll. Little math problems like -4 plus 0 plus 5. Looks like +1's my first answer. -2 plus 6 plus -5. Looks like -1 is my next answer. Oh, this is good. 0 plus 0. I can do that math. 0 plus 0 plus 4. Got a 4 for that one. And then, oh, I can do this math also. So the 0, the 4, the -4 looks like a 0 left right there. Okay, so you've got these answers. Your 1, your -1, your 4, and your 0. And then, hey, it did turn out to be a 2 by 2. I can get my final answer. I can squeeze it in real quick. Here's my final answer. Here's 1, -1. Here's 4, 0. So final answers for my final 2 by 2 in right there. Multiplying matrices, rows connect with columns. That's what you got to remember.